Hi, my name is George Semaganda, and I'll dive straight into where my colleague Eddie stopped at. I'll do the EDA visualization, and yes, we basically use the cargo notebook for our EDA. Then we also did processing for the generic and the data sets we got that were specifically for Uganda. Then we did data cleaning, imputation, and feature engineering. So that is a link to our cargo notebook. So basically, this is a dashboard of our cargo. You look at we imported pandas, then we had the original data. That was a CSV file where we extracted only Uganda from the original data, and then we got a CSV file which we use for our model training and prediction. So basically, these are some of the findings. The histogram, which we plotted the frequency against NDVI mean, then still histograms. These are basically the findings from the different models that we used. So basically, if you look at the box plot, we have some outlier here. It is the NDVI that was close to zero point 0.2, and then fuse of 1.0. There's some outlier there. So if you look at the scatter plot still, that is what we have. And yes, let's look at briefly the bar plot, which has higher fuse at some points, but most of the we are keen. Most of these points with higher fuse are Rua. I see here Yumbe, then Kitgum, basically northern Uganda, where they experience their high chances of drought and maybe famine from those ends. So basically, that is it for the EDAs. And if we look at our Grafana dashboard, this is how it looks like. If you look here, you see the greens. That's where we can position we can access our model from, where they are green. So basically, Grafana helps us to keep logs of activity that is happening with our deployed model on render. So this is basically a dashboard to Grafana. If you look at it here, then if you look at the ML flows, for the ML flows, basically we used Git. We did experience tracking, model versioning, and deployment. Then the artifacts used, we used ML flow parameters metrics, and then the train model. So basically, this is our Git. We used GitHub for our model versioning. Yes, so DVC and Git both uh, move hand in hand. So the results, this is the results we have is we trained five models, and we were in position to get data output from five of them. But here we have random forest with the lowest mean square value, and then the R squared is the highest, so meaning it was the best of all the five models we trained and tested. So random forest of all the five models was the best model. So basically that is it. Let me invite Ronnie to come and take us through the CI, the integration of the of our project.